in this example, instead of finding the distance of the segment, we're going to be given the distance, and then we're going to look at how can we find the value of the x or y value in the coordinate. So if you look at the first example, it says find the value of t if the distance from 3, 4 to t, 8 is 4 radical 2. So you're trying to find the value of this x coordinate. So what you're going to do is you're going to use the distance formula because they're giving you the distance. So if they're giving you the distance and you have 2 coordinates, you're going to plug into the formula. That's the relationship that you have between these 3 things. So distance formula is the change in x's squared plus the change in y's squared. My distance is this, 4 radical 2, so that's going to go in. So 4 radical 2. This is going to be like your x1, y1. This will be your x2, y2. So when I go to plug in, subtract the x's, so it'll be t minus 3. And then subtract the y values, so 8 minus 4. And then we simplify. So I can combine these. I'm going to go ahead and do that. So I have 4 radical 2 equals, can't combine these, so you're just going to have to leave it. So this becomes plus 4 squared. So that's going to become 4 radical 2 equals square root of t minus 3 squared plus 16. Now, a common mistake is people want to break up the square root with the plus. You can't do that. This whole thing has to stay under the square root. So you have to think back to algebra. What's the opposite of square rooting something? So the opposite of square rooting something is to square it. Squaring and square rooting undo each other. So what you're going to have to do, though, if you square the right-hand side, you're going to have to square the left-hand side. So we're going to square both sides to get rid of that big square root so that I can deal with those numbers underneath. So when I square root the left-hand side, think of it as you have to square each piece. So if you square 4, you get 16. If you square a square root, they cancel each other out. So you get 2. Square root of 2 squared is 2. And then on this side, the square and the square root, they cancel each other out. They undo each other. So you're left with what's underneath. T minus 3 squared plus 16. So then over here, you have 16 times 2 gives me 32. Just carry this side down. And I'm trying to get t by itself. So move this 16 over. So we get 16 equals t minus 3 squared. Now, you've seen problems like this last year in algebra. When you complete the square, you end up with something that looks like this. And if you remember, if you're trying to get rid of this squared term, there's 2 ways you can do it. You can multiply all this out using the box, or you could just take the square root of both sides. It's called the square root method because it's a whole quantity squared. The easiest and the shortest way is just going to be square root both sides because square rooting a square, they undo each other. They're opposites. They cancel each other out. So on this side, I'll get 4, and then over here I have t minus 3. But if you remember, anytime that you square root a variable that's been squared, you're always going to have 2 cases. So you should have a plus or minus. It's a plus or minus on this side since you're squaring. It's just like when we had c squared equals some number. When you square root, it's c equals plus or minus. So since the variable is on this side, it's the variable equals plus or minus the square root of that. So now from here you have your 2 situations. You have positive 4 equals t minus 3, and then you have negative 4 equals t minus 3. So then just solve it for t. So add 3 to both sides. So you get 7 equals t. Add 3 to both sides. You get negative 1 equals t. So there's 2 answers for this. So the possible t values are 7 and 1. And both of them would make that distance 4 radical 2, which is what the original problem was asking.